Hello everyone, this is Thiago Alves. I'm the CEO at Autonomy and creator of the OpenPLC project. On this video we're going to do a quick overview of the OpenPLC Editor v4 and we're doing this by creating a project, an irrigation controller. This is by no means a practical irrigation controller. It's more like a theoretical approach to this, just to demonstrate the features and the abilities on the new OpenPLC Editor. So keep that in mind before you start taking notes on the implementation of this controller. The idea here is just to demonstrate the capabilities of the editor, how it can interface with different programming languages in the same project, and hope this will be a very hands-on and practical guide to the new editor. So let's get started. This is the new v4 editor, the latest release. And on this release, we have support for all the 4 languages defined on the IEC standard. Just one is missing, that's SFC. It's going to be added later in the future. But as you can see from this first view, right when you open the editor, you have a list of all the recent projects that you've worked on, and you also have the ability to create a new project. So let's just go ahead and start our new project here. This is going to be a PLC project, and let's call it Irrigation Controller, and let's give it a path. I'll just select somewhere here, call it Irrigation Controller, create a folder for that, and put it there. Okay, then we can pick the language we want to use for this project. As I said, we have 4 languages supported here. I want to do this project in function block diagram. I think it's a great language to have your master view of your design. And we're gonna place in blocks in this master view on the main program. And we can define these blocks in any other language we want. So I think it's a neat way to build a project by just using FBD as the main program. So once we create the project, we get here in this main view, the main program created here, and on the resources you already have your task and instance associated with this main program. So everything is set and ready for you to start programming your project, right? And one of the cool features of the new editor is that not only these panels are resizable and very responsive, but you also have the ability to change, themes. So for example, I can go here and make it dark. And this is really good when you're programming, it's easy in the eyes if you have to stay looking at this for a long time. It's much better to do this on a dark theme than on a light theme, but it's up to your preference. We're going to just continue using the dark theme from now on. So on an irrigation controller, I think the main thing we need to do to start is actually to define states for our controller. We want our controller to start irrigation at a given time. For this particular example, we're just going to read a sensor, a moisture sensor, and if it's low, just start irrigation for a certain period of time, right, until the moisture is okay. And that's a very simple approach. We're also going to have manual control to override, instead of the automatic read the moisture sensor, we just have the manual control where you turn on, the irrigation and turn off the irrigation. So for this, we can realize that just by this definition, we do have a lot of states, right? So I think we should start by creating a new data type for us, and we'll call this irrigation state, right? And this will be an enumerated. And an enumerated data type allows us to create different states, right? And it makes it more user-friendly when you're reading the code. Instead of just using numbers for different states, you can actually use words or names. So let's call the first state stopped. So the irrigation is not doing anything, is not turning on the valve to start irrigation. The other one is running. You can call it irrigating or any other word you want. And finally, we'll have a manual state, right? These are all the possible 3 states on our simple irrigation controller, right? So let's get back to our main here. Now it's time for us to create this main function block. This is gonna be the irrigation controller, right? And the things it's gonna have inside. So for this main block, let's go ahead and create a function block here. I'll call it irrigation main controller. And then I'll pick ladder diagram for this function block. All right, now what we need inside this function block? Well, let's start with state. So I need to know the state that my irrigation controller is running now. And this is gonna be an irrigation state, all right? Then I also need a moisture. So this is your moisture sensor, right? So basically this is a Boolean input that goes inside this function block saying, hey, this is the sensor is saying we're in low moisture, right? So it's just a true or false value. We're not really reading an actual moisture value sensor. We're just getting already the data that it's either low or it's acceptable, right? And the next one that we'll need here is let's call it Tmax. This is basically the maximum time that we're allowing the controller to turn on the irrigation. So let's say that I don't want to run this for more than 5 hours. So even if the moisture sensor is saying it's low moisture, I don't want to overrun it, right? So this is another input for my block saying the maximum amount of time. Because it's a time, let's just pick time for this input, right? And finally, for this block, we'll also want another output here. Let's do it instead, make the state in and out. So basically, I receive this state and I also output this state to the rest of the program, right? So I think that's all we need for this block. Instead of providing, you know, either the valve to turn on and off, we'll just provide a state and change the state instead, right? So let's see how that looks. If I go back to my main program here, you will see that on the library, I have my user-defined block here called irrigation main controller. If I just drag this from my library to the main diagram, I then have this block that is my main controller, right? With the state, moisture, Tmax, you know, the maximum time that it's allowed to run. And you see that the state is also an output. So it receives the state of the system, you know, runs some logic here and returns the state that it believes it should be on, right? Either stopped, running, or manual, okay? All right, so with this, I want to also display the state because, you know, as a feedback, I want to provide, you know, LEDs on my system to say, hey, I'm running irrigation, I'm stopped, or I'm running on manual mode, right? So let's create a function block for this. I can go ahead here and create a function block, and let's call this state display. And let's pick instruction list as the language to create this. This is something very simple, you know, it's just gonna display the state. And even though instruction list is a very primitive language, it's actually, it was taken out from the latest revision of the standard, but you know, for compatibility reasons, OpenPLC still has it and some other editors still have them. So we'll just keep that. And I think it's a neat language. You know, many systems are still running with this. So let's explore that as well. So state display, it's gonna be on instruction list. So what do I need to get here for my state display? First, I need to get the state as input. And the state is obviously an irrigation state, all right? And that's the only thing we need for the input. And then we'll call, for outputs, we can say we're gonna turn on the stopped LED, right? And that obviously is a Boolean, not an irrigation state. We also want to have running LED. And finally, you want to have a manual LED. All right. That's all I need on my state display. So going back to my main view here, I can drag my state display to my diagram. So now I have two blocks. And obviously, I can just go ahead and connect these two together. So for whatever state I have on my system, it's going to send it to the state display, and I'll have three beautiful LEDs turning on here depending on the state that I am at. All right. What else do we need? Well, we need to control either if we're, having the system running automatically or if we want a manual override. So if we are in manual state, I want to be able to override whatever the system is doing and control the valve by myself. Right? So let's do this. I'll create a function block for that as well, and I'll call it manual override. And I'll do this in structured text. I think it's a good one for that. And for this block, I need to receive the state that I'm in, right? And this obviously is an irrigation state. And I also want to receive manual control of the valve. If I'm in a manual state, I want to know what the user wants with this control, if it either turning the valve on or off, right? So let's call it manual valve, or better, manual control. And I want this to be Boolean, right? So this is either turning the valve on or off. And finally, I have my valve as an output. This is basically connecting directly to my actual valve that is turning the irrigation on or off. All right, let's go back to our main tab, and we have another block that we can bring here. That is my manual override, right? And for my manual override, I can also connect the display here. There we go. So we have two blocks, getting the state from my main irrigation controller. So what this manual override will do, depending on the state that the main controller is defining, it will turn on the valve, or if it's in manual state, it's actually gonna turn on or off the valve based on this manual control input here. All right. Okay, so I think we have enough to start, populating this with variables. Let's go ahead and do that. I can either create variables here on the top on these on this plus icon here for the table, or I can drag variables here from the side. This is an input variable, so I'll just drag a variable here, and I'll connect this with my state input. And it automatically detects that this is an irrigation state variable. So I can go ahead and type in a variable name. If it doesn't find a variable to autocomplete to, it gives me the option to create a variable with that name. When I do this, you see that here on the table, it created a state variable with the type irrigation state. That is all correct for me, right? Let's go ahead and do the other ones here as well. Connect this to moisture and connect another one to Tmax. Now, when I'm connecting these variables, I can again just type in another variable name, low moisture sensor. Oh, I mistyped it, sensor. And let me add the variable. Or I can just add a constant. So let's say for this Tmax time, the maximum amount of time I want my irrigation controller to run, I want it to be a constant, right? Not a variable that I will receive from somewhere else. And for this, I will say, for demonstration purposes, 5 seconds. I don't want my controller to run more than 5 seconds. So we can observe this once we are simulating this controller. We don't have to wait for 5 hours. So just 5 seconds, it should stop the irrigation, right? Okay, so we have our variables here in our constants. And you see that the constant receives a yellow on the name or the text of it, just to keep clear that this is not a variable name, it's actually a constant. All right, it's a value that is input directly on that block. All right, for my state display, I also need to connect this to some outputs. So let me connect these outputs here. Just gonna drag a couple variables, another one here, and finally another one here. And you see they all detect this as Boolean. Oops, I misconnected this. Let me zoom it in. Sometimes it's hard to connect things properly. There we go. And once we have all the Booleans, I can, again, just create variables, or I'll do it differently this time. I'll have the variables created here on the table. So I'll have my stopped LED, and this is a Boolean, right? And I'll have my running LED, another Boolean, and finally a manual LED. So those are all indicators, right? On my system, on my panel, on my board, whatever it is, they'll tell me how the system is running. Now that I have these variables here on the table at the top, even if I hide the table to give me a better view, when I'm clicking on the variables here to complete with the name, if I start typing here, it will autocomplete with possible variables that will go here. This is a really neat feature, you know, less typing, more doing. So you click here, I have my stopped LED connected to the output of state display. Do the same thing with the running LED and with the manual LED. All done, right? This is pretty cool, pretty simple. Now, I do need to have a variable for my manual control if I'm in manual mode. So I'll drag another one here, connect there. Let me zoom in again. Connect there, and grab another one for the valve. This is actually the valve, right? Whatever is turning on and off my system. So for the manual control, I will call it manual valve. And whatever value this manual valve has, it will be output to the actual valve, right, on my system. Only if, obviously, the state is manual. If it's automatic, then the controller is controlling the valve through here. All right? So I guess we have the bulk of it. We basically have all the blocks and we connected them together. We added the variables. I think the only thing we're missing here is a way to set the manual control. All right? We will need a special function to set the state, right? We cannot use move blocks or other blocks that are compatible with standard data types, because we created our own custom data type for the state. We'll have to create our own blocks that do manipulation with data for these custom data types. So adding, comparing, setting, all these operations we need to do ourselves, because this is a custom data type. So let's go ahead and do this, create a function, and we call it set state. I like to keep it capitalized, and we'll also use structured text for this. And set state is very simple. Let me expand the table here. All we need to do is get the state as input, and this is obviously an irrigation state, and it will return irrigation state, right? So whichever state it receives on the input, it will spit it out, so you can set a variable to that state. Very simple. And I think I will go ahead and actually implement this just because it's a one-liner. All we have to do is type in set state. That's the name of the function. Receives state. And you see that we have a nice autocomplete. We're going to explore this later when we're in the doing portion, the coding portion of this project. But for now, let's just have the set state as this, right? So it's going to return the state that it receives. So if we go back to our main function here, now that we have our set state in place, we can actually create a diagram here to manually set the state to manual, for example. And for this, I will just grab the set state here, put in my diagram, and I want the set state to actually be enabled with the execution control. So the difference is that you have these enable out pins on my block here, right? So I want that to have the enable activated, because what will happen is when I get a rising trigger on this enable input pin, I want the state to be manual, right? So let me do this, zoom in. I'll put a variable here, and this is connected to state. And for this irrigation state, I want it to be manual. So again, this is a constant, right? Going back to our data types, this is the name of the constant. So if I have manual here on the state, or better, if I have a pulse here on the enable of this block, then manual, this constant manual, will be connected to my, let me connect this up, to my state. There we go, right? Without the enable pin, this manual will be constantly being passed over to state, so I wouldn't be able to get into any other state besides manual, right? But that's not what I want to achieve with this. I want to only have manual sent over to state if I have an action, and that action is defined on this enable pin. So the action is a rising trigger, so it's going up, it's false and then becomes true, rising trigger here. And this rising trigger is connected to another variable, and it's a Boolean variable. So I call this variable set manual, right? I'm adding it. So whenever this variable set manual goes to true, there's a rising trigger, it pulses on the set state function. So basically calls that function once, only once, because it's a rising trigger. And when that function is called, it's going to transfer manual, that's the constant manual, to state. So it's basically changing the state to manual, right? And I'm going to do the exact same thing to get out of manual, right? When the set manual is false or falling trigger, I'm going to transfer stopped to my state. So basically allowing the system to go back to automatic mode. So let's do this again. Go back here to user-defined POUs, dragging in the state. I want this state to be with execution control. And I want a falling trigger. And you see, this is something that I haven't commented much yet. It's just a very neat search functionality for the library. So whatever I type here, it's going to actually filter all the blocks to whatever I typed. So if I want a falling trigger, this is the block. I can drag it here, right? And if I hover over the block as well, I get instructions of what the block is and what type of inputs, outputs it has. So I'm going to connect my falling trigger here to the enable pin, and I'm connecting another variable to the clock. All right. And this variable is actually my set manual, right? The same variable that I used here. And finally, I'm gonna drag a variable here to the state. Oops. To the state, and this is gonna be stopped, another constant, right? So telling the system that it is stopped. And finally, I will connect another variable to the output of this block, and this is gonna be my state. All right, I think we have everything in place. If I click on this button, I see the whole diagram. I guess we're good to go, right? I have my main irrigation controller. I have a display of the irrigation. I have a manual override that finally controls my valve. And I have a set state that will either set it to manual, depending on the value of this variable, or stopped, right? I think the last thing I want to add to this are comments. Comments are important to just give us better visualization of what we have here. So let me drag a comment block here, and I'm gonna right here, this is main irrigation controller. I can make it bigger if I want to, right? It looks good. This is quite obvious, but I just want to use more comment blocks, abuse of those. This is a state display, right? Let me zoom it in a little bit so you can see it better. Hide this, hide that. Talking about hiding, one cool feature about the editor as well is that if you have a lot going on, you can just click on this button and it hides everything for you. Gives you just the code that you're writing, right? This is pretty neat. Make it bigger a little bit. So this is my state display. I might just select all of this, drag it a little bit down here so I can add another comment and say this is my manual override. And I can give better explanations here if I want to, saying, hey, this is overriding the main controller with the status of the manual valve. It can be creative. And I might just drag these blocks down as well and add this as my set manual control. Oops. Right, so this is basically setting the control manually. When this set manual is true, it's gonna move manual to the state, and this is back to set automatic control. Make it bigger, and that's it. I like it. Go back to main view. I like it. We have everything we need. We just haven't implemented anything yet inside these blocks, but I think we have the skeleton ready to rock. And that's how, why I like FBD as a main programming language, because you can just design your system even before you implement it. You can design, the main view of your system. Oh, I need to have this and that and connect these things together. It looks really nice and gives you, a very neat explanation of how your system is working, even if you don't have any code in yet, right? It's a good drawing board for things like that. And then obviously for your implementation, you can do it in structured text, you can do it in ladder logic like we're going to do with the irrigation controller, or you can do it in instruction list for the state display, any language you want, right? But I guess that's it. That concludes our little tour of the editor. I hope you guys enjoyed it, and I see you guys in the next session when we're gonna start implementing some of these pieces here as well. Thank you.